Good afternoon to one and all present here. So the feedback link and the assignment link will be shortly posted in the chat box and also in the WhatsApp group. And the assignment is 12 descriptive questions, then 2 workshop related, that is internal flow and external flow analysis. You have to write on, that is make a assignment in PDF, that is steps and output. Suppose if anybody not having, so you can say around 4 o'clock we have to post that assignment as well as the feedback link in the WhatsApp group as well as the chat box. Sir is joined already. Welcome, sir.
Yeah, welcome, sir. Welcome, sir. Just some few minutes delay. Yeah.
Sir,
Yes, sir.
I hand over the session to you, sir. You can continue, sir. You can continue either coding or.
Okay, sir. Okay, sir.
Thank you, sir.
Thank you. Thank you, sir. Thank you. Up to what time I have, sir?
Sir,
Up to what?
you can continue. There is no formal valedictory function.
Okay, sir. Okay, sir. Fine.
That one. After that, we can
fine, sir.
Giving few concluding words, then close that one.
Okay, sir. Okay. That's nice. Yeah. Sir, Perisamin, sir, you can give me the link for sharing the screen.
Try it again. Please try it again.
Yes, sir. Yes, sir. Yeah, it's working.
Yeah. Okay, sir. Thank you.
Yeah. Yes, participants, if you have any specific in the morning session, what we dealt, you may kindly ask for 5 to 10 minutes because some 14 participants have to be getting added. Once it's added, we'll go for going for coding. Yeah, coding means it's not the real coding. It's not actually we can take it directly full-time flow code, but we can take a transition heat conduction problem and we can solve it. Because if the flow is involved, then we want to solve continuity and momentum, which is not possible at this time. Okay, and we know to come to know about simple algorithm, turbulence modeling. A lot is there. Now only we have stepped into the basics. So we know what is meant by kinetic equation, what is meant by momentum equation, and we come to know what is meant by energy education, but you have not undergone the physical meaning of the energy education. Right now, we know how to discretize the partial derivatives in terms of different form. Uh, uh, up to certain extent. I will not tell we are not we are poor or we are good, but it's okay, it's fine. But still, we have to go for fine to only method and other things to write a complete code. But I can, with the help of the afternoon code, you can imagine how a CFD code in a solver may work. Okay, so that is what my intention is, but it's not the full complete. It's not the complete code. So we can't release the complete code which is used for writing the CFD. That will come only with practice, and it needs more experience. This 5 days will not be sufficient. What are the knowledge we gain may not be sufficient to write a code, but I can give an insight how it may looks like that. Okay, so yeah, if you have any doubts, I'm ready to answer you.
Excuse me, sir.
Yeah.
Sir, is coding is used to obtain a solution for a numerical approach or analytical approach, sir?
Coding is mainly for the numerical approach. Whatever we are going to write it for the numerical only, it is there. Analytical also we can make code. It's not a problem. But here we want to tell what is CFD. So it will be appropriate if you are going to write coding with respect to numerical rather than analytical. Analytical can be done by a normal mathematical professor. A CFD will be jointly developed by both engineers and mathematicians. Even you can see this Navy Stock Exchange is developed by a mathematician as well as engineer. So we can't underestimate the work done by the mathematicians. As well as an engineer should understand the mathematics and he should try to apply in his field, then the results will be more fruitful because he knows the application. That is the idea. If an engineer knows better mathematics, it will be more useful to him. Otherwise, the mathematician should know the application, then he can implement the code more effectively. That is the idea.
Okay, sir. Okay. Thank you.
Yeah. Yeah. Any doubts? Okay. If there is any doubt, I'm ready to clarify. And just a minute. I'll come back. I have stopped sharing the screen. Maybe for another reason, I will tell you. I'm telling. So you can see a video in which I'm explaining the conservation of energy to my students at VIT. It has been recorded for I'm able to get some importance from there. So it is 400. So it has been recorded for the students at VIT for my MTech students. When I was taking the class, actually we have the videos and we have derived the equation for momentum equation also. After that, I was continuing the conservation of energy. But this video, I don't hope so. I may able to share with you because it's a property of VT. I may request them only this video. If they're able to give me, I may give it to Professor Perisami sir. He may give it to the participants, and you may go through the importance of energy education. There are many ifs. If possible, I'll try to share with you. I'm ready to share with you. There's no problem. Otherwise, I'll try to create a YouTube video and give you a link for the energy education because the governing equations are more fundamental and basic and they should be known. I hope everyone is able to see the screen where I was taking the class. If everyone is able to see the screen?
Yes, sir.
Yeah,
Yes.
so I'm able to get 400 kilojoules of work there. So what will happen to the remaining 600 kilojoules? That may be your question. Now E2 will become, now my E2 will become what? 6 dot everywhere. Dot means not a heat flow rate. Not work done per second. The insert 2. So that means what happens? So pose is enough. Pose it. So you may see. But what? Data work there. So any doubt means I am ready to explain you once again. So the answer is. So it is just the video whatever it is taken in the class while I am teaching to the students, and there are a number of videos also. Yeah, it will be. Yeah. Here yeah, this one will go further, and it will also take care of the energy. If I'm going to take a fluid element, yeah, now the energy equation will be there. Body force. Inside of FB, what we have here? Q dot. What is Q dot? Is nothing but the volumetric equation per unit time per unit mass. Volumetric equation per unit time per unit mass. Whether I'm fast, I go with simple only. Simple only. Now let us come to the surface equation where we have to do some work. So this video I will try to share with you, but you will be able to understand because the same ideology whatever we are discussing for momentum. Why I am not going beyond this one means it's not covering the video, so I am trying to restrict this area. Okay, yeah. Okay, fine. And whatever we discussed today morning also, it may be there in another form. You can see here. Yeah, this ADA also. Actually, I had taught with the alternative implicit, finite order discretization, then semi-implicit. Yeah. So explicit methods. Even if I'm going to teach now this explicit method only, I will tell you what is going to be explicit method. This is what the finite difference discretization. This is. Okay, there's some error. And I give the user ID and password to all my students because they are not even allowed to share with the students. Then I have to give the idea or logic given, and even I have taken a class on how to do the meshing with ICCV. That is what's here. Yeah. Okay. Yeah, this video should be there. Then it will be easy, and you can recall whatever we taught in the morning. Yeah. No, this is not there. Okay, fine. Like this, we have some lectures with us where it may be useful to you. So, if possible, I will try to share those videos if VIT permits me to share. Okay, fine. I can't give a complete 100%, but I will try my best. Yeah. Now we have some 143 participants. We'll go with the class. Yeah. I'll go to for screening, screen sharing of this one. Yeah, once again, just I want to show some materials are available. If possible, I'll share with you. And yeah, in the morning, we came to know how to derive dou u by dou x, dou v by dou y, dou w by dou z. Even though we have not derived, but we will be in a position to derive these things. Or dou u by dou y, or dou v by dou x, or dou w by dou y, as well as dou w by dou x. You should be in a position to derive, or you should be in a position to convert these differential forms into first order derivatives into the difference form, either in first order accuracy or second order accuracy. As well as you know, to convert the second order derivatives in second order accuracy, yeah, in one dimension, two dimension, and three dimension. Similarly, we are also know how to derive the mixed derivative, namely dou square u by dou x dou y. In some book, they will follow as f of x plus delta h. Okay. Some books they will follow. It's nothing but similar to your delta x. It may be delta x or delta y or delta z. So they used to have a common term like a delta h. Okay. So we know all these things. And right now we are going to implement this one in our equation and trying to solve some equation. Okay, fine. So this is not required now. So I am not even going to take print screen because already we know these concepts. Yeah. So now anybody can tell me the one-dimensional transition heat conduction equation? One of you can tell me the one-dimensional transition heat conduction equation. Okay, I will tell you. Dou T by dou T. Yeah. Dou T by dou T equal to alpha into
Dou square T by dou x
yeah,
square.
yeah, fine, this fine. So, what is the meaning of this governing equation is there is no fluid flow, which means there is no UVW, which means there is no continuity equation. Because in continuity equation we have what? Dou rho by dou T plus dou rho U by dou X plus dou rho V by dou Y plus dou rho W by dou Z equals 0. If it's going to be incompressible, still all the terms are 0 because dou U by dou X plus dou V by dou Y plus dou W by dou Z equals 0. So there's no need to solve continuity. Similarly, there's no need to solve momentum. It's enough to solve only the energy equation. That energy equation also not a full complete energy equation, only a part of the energy equation. If I already derived the energy equation, in my class I used to derive this equation from the energy equation. So it's nothing but a part of the energy equation. So in our flow physics, having a continuity, momentum, and energy, we are not going to solve the continuity or momentum. When there's no continuity and momentum, there's no need to worry about turbulence because there's no flow at all. So there's no laminar flow, there's no turbulent flow. So there's no need of take care of turbulence. So it's enough to solve only the energy equation. Energy equation also we are not going to solve all the terms. We are going to solve only this restricted term. So I can tell this heat transfer problem is also a part of the complete fluid dynamics problem. It's a part of the complete fluid dynamics problem where we have simplified to a very minimal extent where we can understand the concepts. That is where I want to what I want to explain here. Got it? What I'm telling. So we are just telling here this equation is a part of the energy equation, and we are not going to solve continuity or momentum. When you are going to solve continuity and momentum only, you will feel the real CFD involved there. Especially when you are going to solve the incompressible flow, then you have to highlight the simple algorithm, which is nothing but semi-implicit pressure linked equations. So I don't want to frighten you. If you're going to go by step, all are easy only. If you're going to go by step, nothing is difficult, we can do it. But today we are going to solve this only. But don't go and tell outside that I know completely CFD coding. It's not complete CFD coding, it's only a part of the coding which I want to share with you in order to understand how a CFD code may work for a one-dimensional transient heat conduction problem. Okay, that is the idea. Now, can anyone can help me with what is the difference form of dou square T by dou square? Morning we have seen dou square T by dou square.
T of I plus 1.
T of? Yeah.
T I plus 1.
I plus 1. Very good. It's enough to leave with I.
J.
That's only one dimension. There's no need to put J. Because J is required only for two dimensions.
Yes.
Very good. Yeah.
Minus 2. Minus 2. 2.
Minus,
Ti.
yeah. Ti. Yeah.
Plus T of
Plus
I minus J. I minus 1.
T of I minus 1.
Divided by delta x square.
Delta square. But order of accuracy will be? The order of accuracy will be?
Higher order. Delta x.
Yeah.
X.
It will delta x
Whole square.
Yeah. And can you tell what is dou T by dou T? It is similar to your dou U by dou X. It is similar to your dou u by dou x. Instead of u, you have capital T. Instead of x, you have T. But it may be somewhat difficult. Yeah, you may not be able to answer. So I will help you. Dou u by dou x is nothing but what? It is u I plus 1. I am not writing j because it's one dimension, minus u of I by delta x. This equation, whatever I have written, is not central differencing. It's only the forward marching or forward differencing, isn't it? Because and hence the accuracy will be only first order accurate. This equation will have only first order accurate solution. So it will be plus order of delta x. It is not delta x squared. When I'm going to have central differencing only, it will have what? Your second order accuracy. But I'm going to write only the first order accuracy. You may have a doubt why professor is writing only first order accuracy, why not second order accuracy, why we can't write u of I plus 1 minus of u of I minus 1 by 2 delta x plus order of delta x squared. That is what we expect for a second order. But here I purposely written for a first order because there is some meaning involved in this. Okay. When I'm coming to this dou t by dou t, then it will become t
Yeah.
of
I plus
I
1
plus 1
minus Ti
minus t of I.
divided by delta T.
Then it is wrong. Why it is wrong means this I plus 1 is meant for x-axis, isn't it? This
So,
I plus 1 is meant for what? X-axis. I comma j will come for y-axis also. I comma j comma k will come for z-axis. But now we have replaced I for t, which is not acceptable. If I am able to explain you clearly, okay.
yes, sir.
If you want a two-dimensional, you can write like this. First, I will take two-dimensional so that you will be comfortable. U of I comma j. After that, we will convert it into one dimension. No problem. So let us take a. It is similar to a two-dimensional problem, but it's not there. But simply we can assume it's a two-dimension. So it will be also, if I'm going to write like this is not right. Why it is not right means because I and j stands for x and y. But in the denominator we have time. So time, what is the notation? So we have only x, I, y, j, z, k, and for small time t, we have to use a notation called as n. We have to use a small notation called as what? N. That these I, j, k should be written at the what? Subscript. This is what? Subscript. Whereas this n should be written at the superscript. N should be written as what? Superscript. Got the logic what I'm telling? So once again, I'll repeat it. If you are going to use x, then you have to use I. If you are going to use y, then you have to use j. If you are going to march in y direction, today morning we saw dou u by dou y means we used to tell u of I comma j plus 1 minus u of I comma j by delta y. Like that we are told because j comes for y direction. Similarly, z will come for your k direction. Small I j k. So you not to have the fourth variable, actually the time variable. We should have the notation as n, and this notation n should not be indicated at the subscript. It should be indicated at the superscript. I hope I made it clear until now. Okay, so how to represent, I will tell you. Yeah, if you want, you can remove j. You can remove j. J I have simply put in order to gain confidence because we are more comfortable with the two dimension rather than single dimension or three dimension. That is what I have my experience. So we can have it is u of I plus 1 comma j. Sorry. Yeah, it is u of I. So once again, we should not write that. J. Okay, u of I. This is also not okay. This is also only for your understanding. I written. Now, how I'm going to write dou t by dou t? You can see. So writing dou square t by dou square is very simple. You know already, and you have given a very wonderful answer. There's no doubt in that. Dou t by dou t you are not known, so you are unable to tell. So it is t at n plus 1 minus t at n divided by delta t. What is n plus 1? Similar to your I and I plus 1. Here it is n and n plus 1. What is I? I means this node. What is I plus 1? After certain distance. after certain delta x. So n is means at time t equal to 0, n plus 1 means after some time say delta t. Got the logic? Yeah, just comparing. Once again, I'll tell you. If you want, I can erase it and tell you for you. The formula is not important. The concept is very important. So I can erase this also. This one I just given you for understanding purpose. So you can see here, I can write as, I may write as I and I plus 1. What does I indicates? I is a node at a particular location. What is I plus 1? It's a location after a particular distance, say delta x. It is I plus 1. Similarly, at time t equal to 0, my temperature will be called as at nth time step. At nth time step. After time equal to delta t, my time will be called as n plus 1. My time will be called as n plus 1. Okay. Yeah. So we can see at time t equal to 0, the temperature value will be at n. We have to indicate as n. And after, otherwise I can tell, when time equal t equal to 0, it is indicated as n. When time after certain time, now time equal to 0 here, after some time t equal to delta t, but delta t should be very small because we know the reason. Delta t, after delta t, then here is n plus 1. At time t equal to 0, it is what? N. So whenever time equal to 0, you have to represent at n. And whenever the time equal to what? After delta t, then we have to indicate the temperature as what? N plus 1. So we can write now this as like this. Similar to I, similar to j, similar to k, we can also represent the time with respect to n and n plus 1. N is similar to our I. N plus 1 is similar to our I plus 1. That's it. I hope you got it. Okay, that's a very simple logic. Yeah, now it will be dou t by dou t can be expressed as t, not I, it is n plus 1 because it's u I plus 1. So I plus 1 means n plus 1 minus t I n. N means what? At time step equal to 0. That is similar to your u I divided by delta t. It is forward marching or backward marching or for central differencing. Can anyone tell whether it's forward?
Forward marching.
Forward marching. So the accuracy will be of first order accuracy delta t. So the accuracy will be of only first order accurate. It will not be of second order accuracy or higher order accuracy. Why can't we have backward marching? Can you have backward marching?
No, sir.
Can you have backward marching?
No, sir.
No, because I can't tell I can travel minus 5 seconds. I can start from 0 and I can move forward only. I can't go back. So that is a problem with time. Time always moves in the forward action. So we can't substitute for backward differencing for the time. Even we are unable to substitute the central differencing. Why is not possible? Because central differencing also will become t n plus 1 minus t n minus 1. In time, there is no term called as n minus 1. N minus 1 is minus 5 seconds or minus 2 seconds is not all possible. So we can't have second order accuracy with what? This central difference scheme for this time. So that only I given only the forward marching time step. So time will be always your forward marching, especially when you're going to start. After that, we can have higher order accuracy, but especially when you're going to start, let us go with what? This forward marching. T n plus 1 minus t. I'm sorry, we should not even put, yeah, we can put both at, yeah, we can put as I itself. Okay, if you want, we can put it I itself. So Ti at n plus 1 minus Ti at n. Here it is Ti plus 1 minus 2Ti and Ti minus 1. Okay, so I will erase it and put in a new, not erase it, let us save it, it's important. Okay, so we'll, yeah, it's not happened. No, the screen. I don't know why it's not working. It's fine, it's not working. Okay, anyhow, I will erase it. I thought of taking a screenshot. So the problem is very clear. I have a one-dimensional rod. It's not looking like a one-dimensional. Yeah, I can even draw. Yeah, I will take a one-dimensional rod, and this is A, this is B. So let us say TA equal to say 200 degree Celsius, and TB equal to say 100 degrees Celsius. And I know the metal property of this rod, rho, Cp, and K values of this rod are known. And let us say the length of the rod is 1 meter, for example. Then what we are going to tell means this temperature is going to vary with respect to time also, as well as with respect to space. So that is called as one-dimensional transient heat conduction problem. On the first day, we have taken a steady state case where the temperature will not vary with respect to time. Or once the steady state is attained, we have solved it. Now we are going to simulate a problem where it's going to be transient in nature or unsteady state in nature. So for this particular problem, the corresponding Gaussian equation is this one, dou T by dou T equal to alpha into dou square T by dou square. This alpha is nothing but K by rho Cp. Cp is the specific capacity constant pressure, rho is the density, and K is the thermoconductivity. So we know this rho alpha. This equation can also be solved analytically. This equation can also be solved what? Analytically. That is what one of the person asked, whether we are going to solve analytically. Yeah, analytically we can solve, but that is not involve CFD. So now we are going to solve this equation numerically. Numerically means we are not going to solve directly the PDE by variable separable method or some other method, but we are going to convert the partial derivatives into the corresponding difference form, and we are going to write a iterative code to solve them. That is the idea what we are going here. So now it's very easy to write the right hand side. So it is nothing but T I plus 1 comma, sorry, not comma, it should be minus. So yeah, so minus T minus 2Ti plus Ti minus 1 by delta x square plus order of delta x square comma delta small t. That is this expression I am going to discretize using finite difference method with second order accuracy in space and first order accuracy with respect to time. Like that, you should be able to convert this mathematical equation in terms of words. In terms of what? Your words. Okay. How to write the other side? We are going to write the other side as t only at n plus 1. N plus 1 means it's similar to ui plus 1 minus ui. So instead of ui, I'm going to write as tn. Here tn represents the temperature at time t equal to 0, and Tn plus 1 indicates the temperature after some time it's sub delta t. It can be 1 second, 2 second, 0.1 second, anything. It's after some time delta t. But it should be as much as close to time t equal to 0. That is what we want. Divided by delta t. And here we are going to find the value of the same nodal point. Here I should not be varied. So we have to put only I. Both places we have to put as what? I only. Don't put as I plus 1 or I plus 2 and all. We are going to find the value of the same nodal point. And here, then how we are finding the value? So what is the value of this temperature at this x equal to, let us say this is my I location. So what is the temperature at t equal to 0? Then at the same location only, I am going to see what is the temperature after 1 second or what is the temperature after 2 seconds. So now you can imagine yourself, or I can draw a diagram like this. If I'm going to draw a diagram like this, let us say initially the entire temperature of the rod is 25 degrees Celsius. Let us say initially the entire, because for solving a traction problem along with the boundary condition, you should have the initial values. What is the initial values? You should know what is the temperature of the rod initially. Then only you can solve it. So initial values are necessary to solve a traction problem, whereas it may be given as an additional value for a steady state problem. But without this value, we cannot solve a traction problem. So we know, let us say this rod is divided into some nodes 1, 2, 3, 4, and 5. Okay, which is mean 0.2, 0.4, 0.6, 0.8. Yeah, here it ends actually. Like that we can keep it. Yeah, here I will close it. I hope you also got it. So there will be 4 nodes. I hope you got it. What is the distance now? 0.2 meters. This distance between A and 1 is 0.2. 1 and 2 is 0.2. Here also 0.2. Here also 0.2. So it becomes a B. This point becomes B. So the total length will be 0.2, 0.4, 0.6, 0.8, and 1 meter. So we are going to solve this problem with the 4 nodes. Now the temperature at node 1 equal to what? 25 degrees Celsius. When this value is 25 degrees Celsius at time t equal to 0. After time, we are going to, so this nth time, it is what? N plus 1th time. So now I'm going to find the value of the temperature at the same nodal point 1 only, but after certain time, say delta t. So say after 1 second or 2 seconds. So now it corresponds to n. Now we are going to find n equal to n plus 1 at the same location T1. The temperature 25 will not be 25, it may increase. Let us say it is 35. I am telling approximately. Definitely it will not be 25, it will be more than 25. So now we can see I have not changed the location. The location is same, but with respect to time, this temperature is varying, and hence it is called as transient. Now I hope you got what is the meaning of transient. Transient means here it is varying with respect to time, not with respect to space. The space location is same, but the temperatures keep varying when the time is n equal to 0, or when the time is 0, it is called nth iteration, and when the time is delta t, the iteration is called as n plus 1. Any doubt so far? Any doubt so far with the physics what I have explained to you? So initially I am taking a rod, a circular rod of say length 1 meter, whose left end is maintained at 200 Celsius, and we name the left end as A, and hence its temperature T equal to 200 Celsius. Similarly, the right end we name it as B, and say let us say its temperature is 100 Celsius. These are already given in the problem. Now I am going to discretize numerically using find difference method with the 4 nodes and 5 elements. There are 4 nodes, but how many elements are there? 5 elements are there. How? This is 1 element, 2, 3, 4, and 5 elements are there. There are 5 elements are there. Fine. And at time t equal to 0, initially the temperature is at the entire rod of temperature is 25 degrees Celsius, and at no instant of time, the left hand is taken to 200 degrees Celsius, and the right hand is taken to the 100 degrees Celsius. Now, what is our condition is that we want to predict, or we want to numerically simulate Because yesterday also one person asked, you please tell what is given and what you are going to determine. So these are the data already given. Now I'm going to tell what is the data we have to find out. The data what we are going to find out is that what will be the temperature in the rod with respect to time, and what will be the temperature in the rod with respect to space, because it will vary with respect to extraction as well as with respect to time. So this is governed by this governing equation, namely what? Dou T by dou T equal to alpha and dou square T by dou x square. But this governing equation, if I'm going to solve directly analytically without converting to this difference form, then it's called as analytic solution. There is no CFD involved. But in order to find the value using CFD, we are morning we know how to convert the differential form into difference form like this. And now, just now we learned how to have the time variation of time with respect to variation of temperature with respect to time in difference form. So this is the idea. So Ti at n plus 1 indicates the temperature at a particular nodal position after some time delta T. Ti indicates the temperature at a node at time T equal to 0. I hope everyone is clear with what I have explained so far. If there's any doubt, I'm ready to clarify here because we may not have time at the
Yes,
end.
sir.
Yeah, I hope everyone is able to get it. Yeah, I may erase this one because right now we want to find out the other things. Now let me go with two approaches of solving this equation. One is explicit approach and another is implicit approach. Even in Fluent we may see there's a explicit approach and a implicit approach. So I'll go with the explicit approach. Okay. Yeah, I will tell both what is explicit approach and implicit approach. So in case of explicit approach, explicit, first we'll deal with explicit, then we'll go to implicit. Explicit approach means all the values at the known interval, all the values at known time interval. So now you may not appreciate what is the meaning of this term. Now what I'm going to put means here I put both I and n plus 1 as well as n. But here I given only I. But we have to write as what? Instead of I comma j, we have to write as what? I and n. Isn't it? Because here also we have two coordinates. One along x direction and one along time direction. Similar to I comma j, where we have two spatial coordinates. Here also we have two coordinates, one in space and another in time. So I stands for your space. I have to bring the time. Time means either I have to put n or n plus 1. Now, if I'm going to put n everywhere here, it is called as explicit. If I'm going to put n everywhere here, it is called explicit. Instead of n here, if I'm going to put n plus 1, it is called as implicit. I'll repeat once again because whenever there's a dou square T by dou square, it doesn't be one dimensional. It is also two dimensional. Why? One with respect to space and another with respect to what? Time. So we have to have two variables. So already I have written for the space like Ti plus 1 minus 2 Ti plus Ti minus 1. But with respect to time, I can write either n or n plus 1. If I'm going to write n alone, then that method is called as explicit approach. Instead of n, if I'm going to write at n plus 1 means it is called as implicit approach. What is the difference between n and n plus 1? At n, I know all the values. You please see here. N means what? At time equal to 0. At time equal to 0, it is 1, 2, 3, 4. All the temperatures I know. What is T1 to T4? T1 to T4 equal to what? 25 degree. What T equal to 0 indicates? Nth time step. What does it indicate? Nth time step. At this time step, at this nth time step, I know what is T. Let us assume this is my I. Then this is my I plus 1. So I know I plus 1, I know I minus 1. All the temperatures are what? This is 25, this is 25, this is what? 200. That's what I told. Explicit approach means all the values are all the values are known at a known time interval. At the time interval, we know all the values. That is what at the end. On the other hand, if I'm going to put n plus 1, if I'm going to put n plus 1, the values are not here. The values are not at n equal to, this is what nth time step. This is what n plus 1th time step. N plus 1th time step, what are the values you know? At nth time step, please, I will ask you a question. At the nth time step, whether you know the value of A?
0.
Yes, sir.
What is the time step A? What is the temperature at A at n equal to 0? Sorry, at t equal to 0, which corresponds to nth time step.
200.
25 degrees centigrade, sir.
25, sir.
No, at A.
200.
200.
200.
At B? At B?
100.
100.
B.
100.
100. B is 100. A is 200. A is 200. What about 1, 2, 3, 4?
Not known.
25.
25. No, it's not known. You should not tell. You know that. That is called as initialization. We know the value. It should be given. So this is also known. T1 is 25. T2 is 25. T3 is 25. T4 is 25. At the t equal to 0, corresponding to nth time step. Corresponding to what? Nth time step. Now, what is the temperature at n plus 1th time step at 1, 2, 3, 4? What is T1 at n plus 1? What is T2 at n plus 1? What is T3 at n plus 1? What is T4 at n plus 1? We don't know. Whether we know? No, we don't know. What is TA at n plus 1? What is TB at n plus 1? Can anyone tell?
Remains same, sir.
Very good, very good. Extraordinary. TA will still remain 200. TB will remain still 100 because A and B are known as boundary conditions. The boundary conditions will not vary before and after the simulation. For this boundary condition only, we are trying to simulate the flow physics or the heat transfer within the rod. So whatever the time step, you know the value of TA and TB. But definitely the value at the T1, T2, T3, T4 will be varying. Will be what? Varying. So please take into your mind that the boundary conditions will not vary before and after the simulation, whether it's going to be steady state or even it's going to be transition state. The temperature, the boundary conditions will not vary, and hence these values will vary. These values will vary, and we do not know. These values are known, and we are known. That's what I am telling. If I'm going to put as Ti plus 1 at n means I know the value. If I'm going to put as n plus 1 means I don't know the value. So if I'm going to use the implicit method or the implicit approach, it is at n plus 1. If I'm going to use explicit approach means it is n. All the values are known. Implicit approach, no value is known because all are unknown. So implicit method is somewhat difficult compared to the explicit approach. The explicit approach is somewhat easier, but it will take more time to get converged, or it will take more time to solve. I'll tell you first. Let us try to solve with explicit approach. Is very easy. Then we will try to go with implicit approach. Okay. I hope everyone agrees with me. Okay. Instead of this n plus 1, if I'm going to put n, it is explicit. Instead of n, if I'm going to put n plus 1, it is called implicit. N means all these values are known. N plus 1 means all these values are unknown. That's the only logic. Got it? Even in the unknown, we may know the value at A and B. Even in the unknown, we may know the value at what? A and B. That is what I want to tell you. Once again, n plus 1 means what? Implicit. N means explicit. Here n plus 1 means explicit. Implicit. N means explicit. So now let us try to solve this equation with what? With explicit approach. Once again, I'll do it. Okay, I will retain. I hope you got the problem, what I'm about to speak. So still we can discuss for another 40 hours, 50 hours. Even then we can't complete the entire CFD. CFD is an ocean. So, but I hope this library is quite large enough to gain confidence that you can study CFD from your workplace or wherever you have been. Some basics is given. Okay, I believe that. Now I can come here and I'm going to write, yeah, Ti minus Ti, because there's no variation in the x direction, only in the time direction, n plus 1 and n. N means at time equal to 0, and n plus 1 means time after delta t by delta t equal to alpha into Ti plus 1 minus 2 Ti plus Ti minus 1 by delta x whole square plus order of delta x square comma delta t, which means second order accuracy with respect to space and first order accuracy with respect to time. And here I am going to put only n. Why I am putting n? Because I am trying now with explicit method or explicit approach. The explicit approach is very easy to solve. Okay, explicit approach. In this explicit approach, now out of all the, how many variables are here now? 1, 2, how many terms are there? I not variables 1, 2, 3, 4, 5. Out of 5 terms, how many is known and how many is unknown?
Ti n plus 1 will be unknown. Rest
Only
all
one
will
unknown.
be-
Only one unknown. Only this term is unknown, whereas all the terms are known. Because whenever you are going to see n, your mind should try that you know the value. That you know the value. Whenever you see n plus 1, which means we are unaware, or the value is not known. So now what I'm going to do means, whichever is unknown, now there's only one equation and only one unknown. So directly we can solve it, isn't it? There's only one equation, there's only one unknown. So we can solve it algebraically. So it will be called as Ti n plus 1 equal to, first I am multiplying this alpha into delta t by delta x square. Before taking this term to that side, just I am multiplying this delta t here. So alpha and delta t by this delta x square I have taken it outside by Ti plus 1 at n minus 2 Ti at n plus Ti minus 1 at n. Don't worry about the accuracy now. That's it. Now I can write this equal to a little bit here, and I will erase this equal to. I'm going to bring this term to the other side. So it will become what? It will become plus Ti at n. Whether I'm right? Okay, first I multiply this term here, then I brought this Ti plus 1. Now there is only one unknown and there is one equation, whereas all the values on the right hand side are known, only one known which is the left hand side. So if I am going to substitute all these values, definitely you get the value of Ti n plus 1. What is Ti n plus 1? That is a temperature at a particular node after some time, say delta t. After some time, say delta t. I hope you got it. Now let us try to solve a problem so that you can understand still more clearly. Now also you might got it, but still I want to make it more clear. So this is the final form of the equation what we have established with this explicit approach. Any doubt?
Sir, what about the order term?
Which order term?
Sir, order of delta x square delta t.
Now the order of the term is used to identify how much close you can get the results. Instead of second order accuracy, if you can increase to third order accuracy, your results will be more accurate to your analytical precision. That's the only idea. It doesn't reflect more than that. Yeah.
Okay, sir.
Yeah. If for this problem is a very simple problem, we may be able to get a more accurate results with this order of accuracy also. Okay. Whenever you are going to tell your order of accuracy is what in the second order, you are going to tell fourth order accuracy, your results are more accurate. That's the meaning. If you are going to tell your CGPA is more than 9.5, which means it gives an idea that you are more brilliant or more knowledgeable. Like that. It may not be, but like that it will give an idea. Okay. Yeah, fine.
Yes, sir.
Yeah, fine. And I can erase this explicit approach also. Okay. Arnima. So now we can see, I will take it, I should written somewhat below. Okay, no problem. I will not draw properly. Yeah. Yeah, nothing wrong. I can draw it below also. Yeah. It is 1, 1, 2, 2, 3, 3, 4, 4. So I'm writing 1, 2, 3, 4. Here it is 200 degrees Celsius. The same thing I'm writing because I don't have bigger board. Yeah, 100 degrees Celsius. And we know it is at the nth time step. We know it is n plus 1th time step. It is nth time step. Nth time step means all the values are known. Why I am telling all the values are known? Because I know T1 is T2 equal to T3 equal to T4 equal to 25. This value should be given by the examiner, or it is known well before you are going to do the simulation. So this value T1, T2, T3, T4, 25 degrees Celsius is known as initial condition. Is known as what? Initial condition. Now you tell, you consider a time t equal to 0, I am in Trichy. So after 5 hours or after 3 hours, where I will be, I can calculate. If I am not going to tell at time t equal to 0, whether I am in Trichy or Vellore or Coimbatore or North India or Karnataka or Andhra, you may not be able to predict where I will be after some 2 hours or 3 hours. So whenever you are going to do a transit simulation, you should first of all know what is your position at time t equal to 0. Okay, so I given a very simple and layman example. For example, I want to now travel from Trichy from my home to GCT Coimbatore. So first of all, I should know at time t equal to 0, I'm in Trichy. Then only I am going to drive my own car. After 1.5 hours or 2 hours, where I can be. Like that I can simulate or I can predict. So for doing a transit simulation, definitely you should know the initial values. Okay. And these are the boundary condition. What are the boundary condition? 200 and 100 are boundary condition. It's similar to Trichy and Coimbatore. Trichy and Coimbatore will not vary before and after simulation. For this particular Trichy and Coimbatore only, we are going to simulate. I hope I made it very clear, but don't tell these examples to others. It's not that much good example. Okay. Yeah. Now after time equal to delta t also, now do you say let us after some time, say 1 second or 2 seconds. Then also the temperature at A will be 200 degrees Celsius and temperature at B will be what? 100 degrees Celsius. But whether you know the value at here, what is this temperature is known as? Can anyone tell? At 1, how the temperature at 1 will be noted? What is the notation?
T1 n plus 1. N plus 1.
T1 at n plus 1. We know the value at T1 at n. It is nothing but what? 25 degree. But T1 at n plus 1 is not a known value. That's what I told. Whenever I'm going to use n plus 1, it's an unknown value. Whenever I'm going to use n, it's a known value. You are super. So the value at 1 is known as T1 at n plus 1. Similarly, here we call it T2 at n plus 1. Similarly, we know this what? T3 at n plus 1. This is what? T4 at n plus 1. Now, what is your approach? I want to, you know this value at A and B. Anyhow, I want to find the temperature at 1, 2, 3, 4 at n plus 1. For this only we have this formula. For this only we have this formula. Let us go now. Let us go now and use this formula. T1 at n plus 1 equal to, what is T1 at n? It is T1 at n, isn't it? T1 at n means here, because it's a n. So it is 25 degree. I am writing directly. I hope you can understand. Because this value is nothing but this one. This is what? Here. So from here, I want to go to this point along the time direction. Plus, what is alpha thermal resistivity generally given in the problem? I am going to give now. It is 1 into 10 power minus 7 meter square per second. Okay, that is the value of alpha. And what is delta x square? Let us take delta x equal to what? 0.2 meter in this case. And this value of alpha in delta x, delta t by delta x square should be less than or equal to 0.5. So I'm going to take this 0.25. So what is alpha? Alpha is 1 into 10 power minus 7. Or even we can take a little higher value into delta t by delta x square is what? 0.2 meters. So what will be the answer? Can you find the answer? Delta t equal to 0.25 into 0.2 divided by 10 power minus 7. Or you take, yeah, nothing wrong. You can take it. Yeah.
5 e power 5.
Huh?
5 into 10 raised to 5.
Yeah, now instead of that, you take alpha equal to 1 and 10 power minus 3. Roughly I'm telling, it's not right, but for our calculation I'm telling. Let us take the alpha value instead of 1 and 10 power minus 7. You take this 1 and 10 power minus 3. It may not be true, but simply for our calculation I'm
50,
telling.
50, sir.
What is delta t?
50.
50.
Yes, sir.
So we will be able to find 50 seconds. So we'll be able to find the temperature of the rod after 50 seconds using this formula. So you see, generally this value is called as R. This value is called as what? R. I want to explain this concept also. So I'll reply. I will go through it once again. So this value of R should be less than 0.5 for explicit method. When you are going to use the explicit method, we cannot use R equal to more than 0.5. It should be less than 0.5 only. Generally, it is better to take R equal to 0.25 or 0.3. I am taking 0.25. So what is R? Alpha into delta t by delta a squared equal to 0.5. And in the problem they are given, alpha is what? 1 into 10 power minus 3. And we have taken delta x equal to what? 0.2 meter, because 0.2, 0.4, 0.6, 0.8 and 1. So delta x equal to what? 0.2 meter. Delta x is nothing but the distance between the two nodes. Yeah. So when I'm going to find this value, I'm getting the delta to be 50 seconds. So from this methodology of explicit method, I can find the temperature of the rod at a section at nodal points 1, 2, 3, 4 after say 50 seconds. After 50 seconds. So it is 50 seconds. It is what? 0 seconds. So Ti at n plus 1 equal to 25 plus what is the value of alpha? It is 50, isn't it? No, what is the value of alpha we got? Alpha will be 0.25. Alpha is nothing but R. I should use here 0.25, sorry. R should be equal to 0.25. Yeah, 0.25 into 0.2 will be 0.5. Yeah, yes, 5. So this value is nothing but pure 0.25. Even though we can go up to 0.5, not exactly 0.5, less than 0.5. So less than 0.5, I have taken half of the value, 0.25. What is T I plus 1? I plus 1 means
25.
can you,
25.
yeah, I want the notation because everywhere is 25.
I 2.
Huh?
T2 power n.
T?
2.
Yeah, 2. Because now we are considered this particular position. So I plus 2 will be equal to 1. I is 1. So I plus 1 will be equal to 2. So 1 plus 1 is 2. So T2 at the n minus T I is 1 at the n. What is T I minus 1? T0. What is T0? T0 is nothing but A. Yeah. T0 is nothing but your TA. Yeah, 200. You are right. TA is nothing but your 200. Now you know all the values. What is the value? It is 25 plus 0.25. It is everywhere it is at n only. N1 means here. What about the value here? T2 25. What is the value at 1? 25. So 2 into 25. What is T naught n? T naught means this value. At n means what? 200. So it is 25 minus 50. So I'll get minus 25 plus 200. So it becomes 175. 175 into 0.25. How much? 175 into 0.25. That is a quarter of 175.
43.75.
Which one? 30?
43.75.
43.75. Huh?
75. Yes, sir.
Yeah, 0.75 plus 25. So what is the answer? 25 plus 43.75?
68.
60, yeah?
68.75.
68, huh? Yeah, 68.75 degrees Celsius. So now I got the temperature of 1 as what? 68.75. Got it? Now with these known values, I am able to predict the value of this value at 68.75. For predicting the value of this value, what are the notes I used? I used I plus 1. I plus 1 means 2. I means 1. I minus 1 means 0. So for finding this value, I have made use of these three nodes. So I can tell if I can put a bracket like this. Yeah. So if I want to find 1, I should know the corresponding values at the lower time step 1, 2, and 0. 1 before, 1 after, and the same. If I know all these three values, then I can find the corresponding value at what? At the current or n plus 1 the time step. Similarly, now my question is, if I want to find the value at 2 at n plus 1, what are the nodal values I should know?
1, 2,
1, 2, and
0, 200 degrees, sir.
no.
1, 2, 3.
1, 2, and 3.
1, 2, and 3. Because for 2, 1 node before, 1 node after, in the previous step, 1 node before is 3, 1 node, 1 node after is 3, 1 node before is 1. So, if I want to find the value of the temperature at node 2 in n plus 1, I should know the values at 1, 2, 3. So, I can indicate like this. Okay. I hope you got this answer. I will do it here itself, otherwise it will be very difficult for me. Yeah. I hope I am not slow. If you're okay, I may go a little fast also. Now, what is your nodal position at 2? So, my I equal to 2 now. Because I found the value at 1, now I'm going to find the value at 2. So, it will be T2 at n plus 1 equal to T2 at n plus this value I made as 0.25 for more stability, 0.25. And here, what is the value? It is T. I is 2. So 2 plus 1 is 3. T3 at n minus T. I is 2 here because we have taken I equal to what? 2 at n and T. 2 minus 1 is 1 at n. So what is T3 at n? 25. What is T2 at n? 25. What is T1 at n? 25. So all these values are known. This is 25. This is 25, 50. This is minus 2 into 25 minus 50. So 50 minus 50 is 0. So what will be T2 at n plus 1? It will be equal to T2 1. Otherwise, I will explain it. What is that? So it is my 25. Where it is at 25? This value at n. Because n value you know 25 plus 0.25 into T3. What is T3 at n? This value. This value is also what? 25. What about T2? T2 at n. This is known value 25. What is T1? T1 is what? 25. So what happens to this one? 25 plus 25 is 50 minus 50.
0.
So 50 minus 50 is 0. So that's what I told. This term will become 0. And what is my T2 at n plus 1? It will be equal to 25 itself because this term is 0. So here my temperature is 25 itself, which means, what does it mean when I'm having T2 equal to 25? Can anyone tell? Here also the temperature is 25. Here also the temperature is 25. Can anyone tell what is the answer? or what the physics? I'm not telling the answer. Answer is 25. But what the physics
The
infer from
conductivity will be very low, so that it will take
50
time to
seconds
for
also, after 50 seconds also, I could not find any variation temperature at the node 2. Or I can tell at a distance of 0.4 meter, after 50 seconds also, I could not find any temperature variation. I hope I made the physics. Okay. The person also told the correct answer. Okay. So now we can check. Now what is the next idea? Now what we have to find? T3. What do you have to find? T4. Let us make it fast. You may ask, why sir you made us this value is 0.25? This value can be less than 0.5, but for better stability and better convergence, I have taken the value to be 0.25. So how do you know it is less than 0.5? From the experience. For experience, it is not experience, it is given in the textbook. This value should be less than 0.5. Otherwise, what will happen? You will get divergent solution. You will get the answer, but you will get here instead of 68.75, you will get minus 125. Whether minus 125 is possible is not all possible. So that's what the book has given. So we should, when you are going to use the explicit method, we can't go for the R value more than 0.5, or it should be less than 0.5. Less than 0.5, you can take any value, but I'm taking 0.25 for better stability and safety. Okay, I hope I made it clear about this term. Now my I value equal to 3. So it is T3 at n plus 1. In the diagram, it indicates here, not here. It indicates at here because it's a n plus 1 time step equal to this Ti at T3 at n. This T3 at n indicates here is a known value plus 0.25. I'm sorry, 0.25. Yeah. Then it is T3 plus 1. I is 3 because I is 3 now. 3 plus 1 is 4 at n minus 2 T3 at n plus T2n. There's no need to write, just you can write 432, T4, T3, T2. Got the logic. If it's going to be 3, just you can write 432. If it's going to be 4, you can write 543. So it's very easy. You'll come to know all those things in future. Okay. What is T3 at n? This temperature 25 plus 0.25. What is T4 at n? It is also 25. What is T3? That is also 25. Because all are the nth time step. Plus, what is T2? Once again 25. So what will happen once again here? 25 plus 25, 50, minus 50, this time will become 0. Which means my T3 at n plus 1 is also equal to what? 25. Because this term becomes 0. So this is what? My 25. So once again the physics is heat transfer has not happened up to the point 3, either from the end A or from the end B, even after 50 seconds. Even after what? 50 seconds. With the problem we have taken. With the problem we have taken. Now we have to find the value at a nodal point 4. At n plus 1 time step, at not n, because n already we know the value.
43.75, sir.
Yeah, you have found it out. Very good.
Yes, sir.
So he has found the answer itself. Very good. So it is T4 at n plus 1 equal to T4 at n plus 0.25. This R value into T5. T5 is nothing but your TB here. Okay, no problem. T5 at n minus 2 T4 at n plus T3, because 4 minus 1 is 3. So what is T4? T4 is at n is once again 25 plus 0.25. What is T5? T5 is nothing but TB. It's nothing but 100 minus 2 into, what is T4? 25.
20.
What is T3? 25. Where is T3? T3 is here. What is T4? Here. So it is what? 100 plus 25. 125 minus 50. So 75. 75 into 0.25. How much it is? 75 into 0.25. Yeah,
Final answer is
14.5.
43.75.
17.5. It will be equal to now 42.5.
43.75, sir. Final answer.
43.7.
43 is coming, huh?
Final answer, sir.
Final
answer is
answer,
how
sir.
much? 40? 42 or 43? Because
It's
75,
43, sir. 43.75.
43.75.
I will agree with you. I'm not that much good. Okay, 43.15. So now we can see this is 43.75. What is the next? So now we have found all the answers at time step at n plus 1, isn't it? Are you okay? Now
Yes,
I
sir.
am able to find the value. Yeah, like this. If you want, I can put a red once again. Yeah. So you can see. Now the beauty is I am able to find the temperature of the rod at nodal position 1, 2, 3, 4 after 50 seconds. After 50 seconds. Now in the examination, or if you want to find the answer at 500 seconds, what do you have to do? Now we have found the answer for the temperature distribution in the rod at location say 1, 2, 3, and 4 after 50 seconds. But the question is like this for us. You have to find the answer after 500 seconds. What we can do?
We have to repeat this process for 500 iteration like.
Yeah, very good. We have to do this thing for 10 times. You have to write a C coding with a for loop for I equal to 1 to I equal 10. So when I becomes, instead of I, you can put any letter. Okay, that is loop should go. That is after time equal to 50 seconds, then 100 seconds, 150, 200. How to find the value at, I will tell you here. Now, I hope you got the concept. So now, from n plus 1, I had to go to what? I had to go to n plus 2. Now, in your C language itself, you have to write a code. What about n plus 1 and n plus 2 now? All the values at n plus 1 is known value. All the values at n plus 2 is what?
Unknown values.
Unknown value. I will repeat once again. Now, initially we are known with the value at n. We are unknown the unknown values at n plus 1, except the boundary. I accept it. So, but we are in a position to find all the values at n plus 1. We have found the answer now. Now, actually, we have to find the value at n plus 2. What is n plus 2? At 100 seconds. At what? 100 seconds. But before going to do simulation or before going to do the iteration in your C language, what you have to assign means you assign n plus 1 to n and n plus 2 to what? N plus
N
1.
plus 1.
Got logic? So this value becomes like your nth time step. This n plus 2 will become like what? N plus 1. What is n and n plus 1? N is known value. N plus 1 is what? Unknown. Now only you are going to start once again because you know the known value. Now you are going to use the same principle and you are going to use the same formula to find the value at what? N plus 1. Got logic? Once you find all the values at n plus 2, then make n plus 2 as your n and make n plus 3 as what? Your n plus 1. Repeat the same step. Find the value at 150 seconds. Then once again, if you find the value at n plus 3, make n plus 3 as n and n plus 4 as what? N plus 1. Which means whenever it is n, your mind should strike, you know all the values at the boundaries as of the initial values. Whenever you feel n plus 1, your mind should strike only the boundary values are known and not the intermediate nodal values. But we can find. Any doubt? I hope like this you can mark for 10 iterative steps or 11 iterative steps until you want to find the value at temperature equal to 500. Even you can make a tabular column. How is the temperature varying at 50 seconds? They will not ask only after 5 seconds, 500 seconds. They may even ask what they will ask even they will ask what is the temperature at 50 seconds, 100 seconds, 150. So everything you can make a tabular column. You can put 1, 2, 3, 4 along the along the row ways. Along the column ways, you can put a T1, T2, T3, T4. Then you can plot the values. So we can come to know how the temperature at each and every node is varying with respect to time. And the temperature also will vary with respect to space because T1 is not equal to T2, isn't it? That itself indicates the temperature is not, there is not a, is also varying along the direction. That's the meaning. And after a particular time, what will happen means, after the steady state is, what is meant by steady state means, all the temperature will, at the nodal position will remain same. For example, I will tell the value at T1 is 125. The value of T2 is what? Say 100. I am telling simply. I will not tell it will be 100 because 100 can be only this end. So I can tell the value of T1 is equal to 175. T2 equal to what? 150. T3 equal to what? 125. T4 equal to what? 112.5. And T5 equal to 100 degree because already available. Then what is meant by steady state? I am going to tell now. I am going to tell you what is meant by steady state. Whatever the value I told is simply whatever the value came to my mind or from my mouth. Actual value may be different. But for instance, I'm telling, if I'm getting a value of T1 as 175, T2 as 150, T3 as 125, and T4 as 112.5. Then let us say this is you are getting at 500 seconds. Then you are trying to simulate the answer for 550 seconds. Then also, if you're going to get T1 equal to 175, T2 equal to 150, T3 equal to 125, T4 equal to 112.5, your transition solution has become attained the steady state. Your transition problem has attained the steady state, which means after this steady state, there won't be temperature variation along the time, with respect to time. After 500 also, after 550 also, after 600 also, the temperature will not vary with respect to the node. So now the transition problem has attained the steady state. Whereas still the temperature of T1 is not equal to T2. Okay. So the 20 is called as what? It is distributed in the x direction. I hope I have explained what is now transition. I explained how the transition state may reach the steady state. Any problem which is going to be steady state is essentially transient only. This is what the comment I used to give to my students in the class. Even if you are going to take a steady state problem, initially it will be a transient state only. After a particular period of time only, it may attain a steady state. Initially, no problem is steady state. Even if I am going to apply a flow through a pipe, initially the flow will have variation. After a particular time only, the flow will get stabilized and steady. I hope you got the logic. So no flow in the entire universe is initially what? Steady. Initially all the flows will be transient only. But after a certain time, if you are able to attain a steady state, it's called a steady state problem. Even after a particular time, if you are not reaching a steady state, it is called as a transient value problem. That's it. I hope you got it, what I meant. If there is any doubt with whatever we have discussed so far, I am ready to answer you. Yeah. If there is any doubt, if you do have any doubts, now I hope you got some idea about what is meant by coding. This coding is very simple. You can write in C language or even you can write in Excel sheet. Nothing wrong in that. But Excel sheet you have to write once again. But in C language you can put a loop, a for loop, and you can get the answer. Even you can try with your this one, other things. Yeah. Whether you are able to hear me?
Yes, sir.
Yeah. Now shall we move to implicit method? If you're okay, I'll go to the implicit method. Or if you're enough, we can go with the tool. It's up to you.
Implicit.
Implicit method. Okay, implicit. All are interested to know how does implicit looks. Implicit method is not so easy. Implicit method is not difficult. But implicit method, the unknowns are more. Okay, I'll come to the implicit method. Unable to. Tarnima, print screen. How to make print screen? Print screen. Screenshot. I'll do it. இது அப்ப போச்சு. Yeah. Yeah, no, thank you. Yeah, fine. I have taken the screenshot because it may be useful to you. Yeah, fine. Now I will erase it and try to solve the same problem by implicit approach. I also want to show how to set up the case of access client, the problem what we dealt yesterday. Yeah, you type permits, I'll show. Yeah, fine. So we'll take the same problem, and the governing equation once again is going to be same. So it is dou t by dou t equal to alpha into dou square t by dou x square. So it is ti at n plus 1 minus ti at n. Now you hope you are more familiar how to write with the time derivative. As alpha into ti plus 1 minus 2ti plus ti minus 1. Until yesterday we do not know what is ti plus 1, ti minus 1 and all. Today we learn these things. Delta x squared. Once again, I do not write the order of accuracy. You know that. But instead of writing here n, if I'm going to write n means explicit method. Now I am going for implicit approach. The implicit approach is nothing but what? N plus 1. I'm right only. What is semi-implicit? There's another method called semi-implicit or Craig-Nicholson scheme, where it will be having 50% weightage for implicit and 50% weightage for implicit. Then it's called semi-implicit. I'm not going to teach today, but I have the video what I have in the infrastructure. If it's possible, I will try to share you. Okay, fine. So this is the one. Now, I hope you can imagine the diagram what we had drawn earlier. Now, how many variables are there? How many terms are there? 1, 2, 3, 4, 5. Even though there are 5 terms, you can see this term and this term are one of the same, isn't it? Both are ti at n plus 1. Here also it is what? Ti n plus 1. So totally there are only 4 terms. So totally there are only 4 terms involved. Out of these 4 terms, how many are known, how many are unknown? So there are actually saying there are 5 terms, 1, 2, 3, 4, 5. But the term, this term and this term are one and the same. So I can tell there are 4 terms. Out of these 4 terms, how many are known, how many are unknown?
Only one is known, sir.
Only one is known. How many is unknown? 3 are unknown. No, out of 4, one is known. This only is known, isn't it? Because it is n. Whenever is n, it is known. Whenever it is n plus 1, it is not known. This is n plus 1, this is n plus 1, this is n plus 1. Whether I have to put a mark here, no need, because the same time is here also. I can combine them. So there are 3 unknowns and 1 known. There are 3 unknowns and 1 known. Whether it is possible to solve a equation with 3 unknowns. If we have 3 equations and 3 unknowns, we can solve it. But now we have 1 equation and 3 unknowns. Whether it's possible to solve?
No, sir.
How? But algebraically, it's not possible. We can't solve it algebraically. But we are going to form a set of linear algebraic equations, and we are going to form a tridiagonal matrix algorithm. Because of that, we will be able to solve it. Okay. So this one, if we are going to tell in words, you will not appreciate much. So let us solve it. At the end of the solving the thing, you may appreciate how we are able to solve this equation. As Madam told, it's possible to solve, but not in a normal way, but in a different way. Okay, yeah, fine. So, yeah, as usual, I will write. So it is ti at n plus 1 minus ti at n equal to alpha into delta t by delta squared of ti plus 1 at n plus 1, isn't it? Minus 2 into alpha into delta t by delta x squared of ti at n plus 1 plus alpha into delta t by delta x squared of t I minus 1 at n plus 1. I hope everyone got this formula how I written. I had taken this alpha and delta t by delta x squared, and this term is common to all the three terms. So I multiply individually with this term, this one. When I'm going to multiply inside, it will have minus 2 also. This is minus 2 into alpha delta t by delta x squared. When I'm going to multiply this term, it will be only alpha and delta t by delta x squared of ti minus 1 at n plus 1. Just a minute. Yeah, now we'll come back. As well as now we can retain this t minus ti n alone in the left hand side. Why? Because it's a known value, there's no problem. Now I'll take this value also to the right hand side and I'll combine with this term because both are ti n plus 1. So there's no change in the first term. It is alpha into delta t by delta squared of t I plus 1 n plus 1 minus 2 alpha delta t by delta squared into ti at n plus 1 minus ti at n plus 1. How this minus sign come? Because from here to here plus alpha into delta t by delta squared of ti minus 1 whole power n plus 1. Then I'll erase this two things which are not required now. Even everything is not required. We want only the final expression. So I hope you know what is the implicit method. In implicit method, everything is at an unknown type step, which is at n plus 1. Now your mind always try n plus 1 means unknown values, which is nothing but your implicit method.
Sir, for these two methods, will the accuracy of the solution vary, sir, for explicit and implicit?
Yeah, implicit method is more accurate. And I can't tell openly like that. It is not that much good. Once again, it will come through experience. In some form, in some problems, implicit method is more. Implicit method is having more stability, and it will converge fastly. But it requires more amount of work. Okay, explicit method. If you are able to solve by explicit method, it's fine. But if you are not able to solve the through explicit method, you may try with the implicit method. That is what we used to tell. Okay, to the students. Yeah, when the physics is going to be much more complex, we'll try to solve all the students to solve with the implicit method, because implicit method has a more robustness in terms of stability rather than accuracy. Accuracy we have to confirm with your validation value. Okay, we are always talking here about the stability. Stability means when the solution is going and running, it should not come away. You should try to give some answer to us. That is sometimes what happens means the solution will diverge. Instead of going to 10 power minus 4, all will go to 10 power plus 4, and all the solution will come out, which means that the computer will tell, I am unable to solve you, unable to solve the kinetic equation, momentum equation, because your errors are more. In such a case, the implicit method is more beneficial compared to the explicit method. I hope I answered you partially. Yeah, I can't answer it fully also. It will come with experience. Okay, yeah, fine.
Okay.
Now we can see out of these two terms, which one we can take common? Out of these terms, which one we can take common?
Ti n plus 1.
Ti plus 1 can be taken as a common term. So I can write as Ti at n plus 1. Okay. So it will become what? I can even take my, yeah, I can even take my minus here. So it become what? 2 minus, how it will be? Yeah, 2
alpha delta t.
Yeah. 2 alpha into, sometime will become blank. Yeah.
Delta t by delta x square.
Yeah, thank you. Delta t by
X square
delta
plus
square
1
plus
plus
1.
1.
Very good. Plus 1. So if I'm going to multiply minus into plus 1 minus 3i plus 1, this term will get it. If I'm going to multiply this term, it will be minus 2 alpha delta t by delta square into tn plus 1. So these two terms can be combined to be like this. Yeah, you are right. In order to avoid the space, in order to have control of time also, I'm erasing this one and I'm going to replace. I hope you will agree with me. So I'm going to write it here. Minus 2 alpha delta t by delta squared plus 1 of ti n plus 1. So this is the second term, this is the third term. So now I can erase this term. I hope you got it. So we worked on the second term and third term and made as combined second term. So this is the equation. Now I am going to write the same equation as a capital A into t I plus 1 n plus 1 minus b t I at n plus 1 plus, can I put C? Can I put C?
Yeah.
Yes,
Not
sir.
C. Not C.
Sir, it's
Yes, sir. Yes,
A.
sir. A.
Both the same. Here also it is alpha and delta t by delta square. I am putting A equal to alpha and delta t by delta square. This is also alpha and delta t by delta square only. So I have to put A only. Okay. So A into t I minus 1 at n plus 1. Why I put B? B is nothing but 2 into alpha and delta t by delta square plus 1. So this value I am calling as B. Why I am calling them as A and B? Why I am calling as A and B? Because alpha is a constant, delta t is a constant, delta square is also a constant. Similar to the R value what we mentioned earlier. So these values are constant. So I am putting A, B and A, which is equal to what? Minus Ti at n. Are you okay with this equation now? Any doubt? How to find A? Yeah, as in the previous one, they given alpha. Alpha equal to 1 into 10 power minus 3. What is delta t? We had to find it out. What is delta x squared? Delta squared equal, delta x equal to what? 0.2 meter as the previous one. But here, we can even take the value of r to be 0.5. Your answer will not be wrong. Last time I told, if you are going to take the value of r, we should take the value of r less than 0.5. If you are going to take given 0.5 or above, you will have erratic answer. Say, we are going to work between 100 and 2 degree only. But in the answer, you will get a 500 degree. Sometimes you will get minus 50 degrees Celsius. So we will get erratic answer in the explicit approach if you are going to use the r value equal to 0.5 or more than 0.5. But in case of implicit method, you can use still the R value to be 1 or 2 also. But they are asking us to go with R equal, at least we can go with the 0.5. Minimum value I can go is 0.5. Still, if you want to have better fast measurements, you can try with even 0.75. 1 also you can try. But generally, we are allowed to go at least 0.5. So that is the advantage of the implicit method. When I am going to R equal to 0.5, so 0.5, I will erase it and do it. So R equal to alpha into delta t by delta squared equal to 0.5. So what is the value of delta t? Delta t now will equal to 100 because when we have 0.25, we got the delta t value to be what? 50. That will be twice. So we can simulate after 100 seconds directly. That is, this method of SSC method will be at least, implicit method will be at least twice as that of your what? Your explicit approach. Okay. It will be twice the speed of the explicit approach. Or we can move fast. Instead of 50 seconds, we can move here to 100 seconds directly. That is the advantage of the implicit method. So now this is nothing but R is nothing but what? A is 0.5. This is also 0.5. B we have to calculate. Minus 2 into 0.5. What is minus 2 into 0.5? 1. 1 plus 1 will become 2. So it is minus 2. So B will be equal to 2. I can tell from this one, we can find the value of A as what? A is nothing but your R only. A is nothing but what your all R only. So A is 0.5. B is coming to be 2. And A is once again 0.5. So now we got an expression for this equation. Are you okay? A, B, and A. I hope you got it because this value is what? 0.5. 0.5 into 2 will become what? 1. 1 plus 1 will become 2. So B equal to. That's what I told here. So I will erase it and do it. Or I can directly write it here. A is what? A is nothing but, I will erase here also. I will erase here also. Yeah. So it will be point. So 0.5. It is what? 2. It is what? 0.5. But still we will not be happy because there are 3 unknowns. N plus 1 means 3 unknowns and 1 equation. How to solve it? Let us make it fast. Yeah, now I will draw with the diagram. Now it is what? N, N plus 1, yeah, and N plus 2. It is eighth time. For example, I am drawing N plus 2 is not required, but for your understanding, I am writing. At always A and B will be 200, and I'm trying to attack the same problem with the implicit method, 200 and 100. So 1, 1, 1. It is 2, 2, 2. It is 3, 3, 3. It is 4, 4, 4. Okay, 1. Now we are going to find. Now which one we are going to find in this equation? Now you know the values. Whether you want to find the values at n, whether you want to find the values at n.
No, sir.
No, we know all the values at n at n time step. That is T1 to T2 equal to T3 equal to T4 equal to what? 25. So now we are going to find the value from here to here. So let us call this as 1, 2, 3, 4. So let us move for I equal to 1, 2, 3, 4. Now let us take I equal to 1. I equal to 1 means where? Here. Even if you forget about n plus 2, that's not required. It may confuse you. So in your mind, you can think this is n plus 2, n plus 3, n plus 4 and all. Right now, it's not required. Okay. So I am telling here, this is what? I equal to 1. Why? Because here we are going to for this higher type step where the value should be known. Okay. When I equal to 1 means we have to substitute the value here. So it become what? 0.5 into T. 1 plus 1 is what? T2 at n plus 1. Whether you know this value T2, whether this 2 is this 2 or this 2. I will put
N
like
plus 1, N plus 1 too, sir.
yeah, you are right. So it is 2, it is 4. So this T2 means here, which also not known. Minus 3, T, what is I write here?
T1.
T1, because I is 1 at n plus 1. So what does it indicate? 1 in red color. 1 in what? Red color. Plus 0.5. What is T1 minus 1?
T0.
T0.
TA,
Where here
TA,
or here?
TA.
200.
Below, sir.
200.
Yeah, not below. Here
Yes,
only.
sir. Yes,
200.
sir.
But here also we know the value. Yeah, TA
2%.
at n plus 1. I am
Yes,
telling you the value is here and not here. Both
Okay.
will be same, but we are here location only. So it is TA. TA is nothing but your known value at n plus 1 equal to what is minus T1 because I is 1. Where is n?
Below.
Below.
Below. Below means which value? What is the value?
N.
25.
Yeah, this
25.
is blue color, which is 25.
25.
Yeah. So this value is also known. This value is also known, isn't it? TA is 200. 200 into 0.5 is how much? 100. So you take it to the other side. Minus 100, minus 25, minus 125. I hope you got it. I am a little bit fast. I will repeat once again. T1 is 25. T1 at the end is what? 25. What is this value? TA is what? Here. Here is also 200. 200 into 0.5 means 100. Here this plus 100. When I go to take it to the other side, become minus 100. Already this minus 25. So minus 100 minus 25 is minus 125. Is what? Minus 125. Okay. So now the equation becomes 0.5 T2 at n plus 1 minus 2 T1 at n plus 1 equal to minus 125. So this is the equation number 1. This is the equation number 1. Any doubt here? How we got this expression? Here, this is what this implies. Equation number 1 implies like this. So one equation number implies 0.5 T2 at n plus 1 minus 2 T1 at n plus 1 equal to 1 minus 125. Even we are unable to calculate this one. Why? Because there are two unknowns and one known. We cannot solve it. Okay, let us retain. Now instead of I equal to 1, let us have I equal to 2. When I'm going to have I equal to 2 plus 1 become what? T3. This T1 will become what? T2. This TA will become what? T1. Because here it is T0, now it will become T1. I hope you got it. And this T1 will become what? T2. Whether you want to write once again or you got it. You increment all the values by 1. Here it was a 2, 1, A. Now we made us what? 3, 2, and 1. I hope you got it. Harish is just substitute the value of 2 here and write the equation, you will get this answer. Okay. Are you okay?
Yes, sir. Yes, sir.
Yeah, fine. So now what is 0.5? Where is T3? T3 is here. Whether we know, don't know. Okay. So it is 0.5 T3 at n plus 1 minus 2 T2. Whether you know this value T2 at n plus 1? That is there, it is in red color, we are unknown. Plus 0.5 T1 at n plus 1. Whether you know this value? Whether you know this value? No.
No.
This is also not known. What is T2 at n? Yeah, we know. This value is what? 25. So it is minus 25. So we got the expression for equation number for the node 2. Similarly, we have to form two more equation. I hope I can erase because you got the logic. Wherever it is n plus 1 is unknown. Wherever it is n, it is known. That's it. So there's no need of this diagram here after. So 3 implies. Now I equal to 3. So it will become 0.5 into, this is the governing equation. So it will become T, I equal to what now? T. I have to change it. So now I equal to 3. So 3 plus 1 is 4. So T4. N plus 1. N plus 1 means not known. Okay. Minus 2 T3 because I equal to 3 now. At n plus 1 not known plus 0.5 T. 3 minus 1, 2, which is also not known because it's at n plus 1 equal to what? Minus T4, T3 at the n. T3 at n means known value. So what is the temperature? 25. If everyone is able to get the third equation also, I hope you might get the third equation also. Then let me come to the final equation, fourth equation. Now I equal to 4. Instead of 3, I equal to 4 now. So it becomes 0.5 into T. 4 plus 1 is 5. 5 means the right hand side node. Right hand side is nothing but what you are TB. TB is nothing but 100. I hope I know this value. Are you any doubt how I put 100 here? Now I equal to 4. So I plus 1 will be what? 5. 5 is nothing but what? B. At which time step? N plus 1 the time step. Even at n plus 1 the time step, my boundary values will not vary. And hence my TB is there 100 only. So I put directly 100 because there's no time for us. Minus 2 into T4 because I equal to 4 at n plus 1 plus 0.5 into T3. Why T3? 4 minus 1 is 3 at n plus 1. N plus 1 means not known. Equal to, what is Ti? T4. T4 is also minus 25. Now what is 0.5 into 100? It is 50. 50 when I'm going to take it to the other side become minus 50. So minus 50 plus minus 25 will become minus 75. So I can change these two terms as one term because this is also constant, this is also a constant. Take this plus 50 to the other side. It become minus 50. Already there's minus 25. So it become minus 75. So I will erase this 0.5 into 100. And I will erase this minus 25 also, and instead of this I will put as, so we have now 4 equations, okay, and for the 4 nodes. Now this 4 equation we can solve it. Yeah, how to solve it? I can erase it now. The other things you see, I can erase it. We are about to complete it. So you can see I'm going to form a matrix. The matrix is like this. T1 or nodal 1. It is not even 1. We can put a 1. Or T1, T2, T3, T4. So this one into T1. Otherwise, we can put there 1, 2, 3, 4 itself. T4 equal to constant. So here, instead of T1, T2, T3, 4, I may put as simply, I may put as 1, 2, 3, 4. This value is nothing but my constant. Now I am going to write in the form A x equal to B, where A is a matrix, B is a constant. I am going to find the value of x. Okay, that is the logic. So here's the matrix I am going to write. How I am going to write? You see, 0.5. Sorry.
2 minus 2.
Yeah. It is minus 5. No.
Minus 2.
No. Yeah, T1 is there. Yeah, you are right. It is minus 2.
0.5.
Because T1 is on the other side. So first we have tried from the right to left. Then it is what? 0.5.
0, 0.
Then 0, 0 is equal to minus 125. I will help others how to write this equation. You see here, minus 2 into T1 plus 0.5 into T2 plus 0 to 3. 0 to 3 means there's no T3 plus 0 T4, which means there's no T4, equal to what? Minus 125. So I will repeat once again how to write the equation. Minus 2 into T1, okay, is there, plus 0.5 into T2 is equal to what? Minus 125. Because the last two terms doesn't have any meaning. This is also, we can imagine it is at n plus 1. Okay, so we can easily identify. Now let us come to the second equation. It is, we have to move from here to here. Yeah, we will move like this from right to left. So it is 0.5
minus 2.
T1. Yeah, then it is minus 2.
0.5.
0.5.
0.
0. And the answer is minus 25. How to study this equation? 0.5 T1 minus 2 T2 plus 0.5 T3 equal to minus 25. Because there's no T4. 0 T4, there's no need to mention. I hope you got it. Now let us come to the third equation. It is 0.5 T2. Yeah, there's no T1. It starts only with T2. So you don't write anything for 1. You put a 0. For T2, you put as what? 0.5.
Minus 2.
Yeah, T3 is minus 2.
0.5.
0.5. Now, how to study this equation? Don't study with the T1. You start with only T2. 0.5 T2 minus 2 T3 plus 0.5 T4 equal to minus 25. I will write minus 25. Then you start from here. There's no T1, there's no T2. So put 0 as well as 0 for T1 and T2. Then it is 0.5 for T3 and minus 2 T4 and the constant is minus 75. And the constant is what? Minus 75. So we have entered with the matrix, and I appreciate the person who was able to print this terms well before. Since I want to explain to all the participants, I explain slowly. But this is the way how we can convert the equation into matrix. It is not difficult. How to read the equation? Minus 2 into T1 plus 0.5 into T2 equal to minus 125. It will be here. 0.5 T1 minus 2 T2 plus 0.5 T3 equal to minus 25. 0.5 T1, 0 T1, so leave T1. 0.5 T2 minus 2 T3 plus 0.5 T4 equal to minus 25. 0.5 T3 minus 2 T4 equal to minus 25. So we got a matrix. Now, I can erase this equation. I am also unable to save a print screen now. So this matrix is known as, you can solve this matrix by any method, by making upper triangle or lower triangle, and you can get the values of T1, T2, T3, T4. All the things you can get it. You can even solve this matrix by Gauss-Seidel and Gauss-Jacobi. There is an iterative method. That also you can solve this matrix to find the value of T1, T2, T3, T4. Okay, and you can see now this matrix is called as the main diagonal. Sorry, not this matrix. This diagonal is called as the main diagonal. This green color is called as the right diagonal. And this black color is known as the left diagonal. So we can see the elements are there. Elements means some numbers are there apart from 0, only in the main diagonal and the right diagonal and the left diagonal. It is everywhere it is 0. This type of matrix is known as tridiagonal matrix. This type of matrix is called what? Even if you are going to have, instead of 4 nodes, if you are going to have 20 nodes also, you will end up with 20 equations. But you will have the elements only in the main diagonal, right diagonal, and the left diagonal. All other elements will be 0. This is the beauty of this implicit method. Okay. So, because there is only 3 variables, we will end up only with what? Tridiagonal matrix. If you want to improve the accuracy, instead of 4 nodes, if you are going to put 20 nodes, it's good. You will have a 20 equations like this. But the elements will be only in the 3 diagonals only. And hence, it is called the tridiagonal matrix. This tridiagonal matrix can be solved directly using an algorithm called as Thomas algorithm, which I'm not going to teach now. But this method is called as DAT method. That method means there is no need to go for iteration. We can get it directly. So this method is called as DAT method. And there are certain formulas to calculate this method, and even you can program it. And my MTech students and even previous batches, they have written their own C code, MATLAB code, and Excel sheet. That is my. I used to give the assignment to the students as you try the Thomas algorithm using Excel sheet. You try the same thing using MATLAB. You try the same thing.
Excuse me, sir.
Yeah.
Sir, value will be calculated.
Sure.
These values are calculated if required.
So you have already calculated.
Yes, sir.
Yeah, good. What is T1?
72.24.
72.24. So
T2? 38.
38.99. Okay. T3?
33.73.
33.73. T4?
40.
40?
45.93.
45.93. Very good, very good. What's your name?
Sir, Himanshu.
Himanshu. Okay.
Yes, sir.
You are from VET?
No, sir. ICT. Mumbai.
Very good. Okay, very good, very good. Congratulations. So we are able to solve this matrix, and we are able to find the values of T1, T2, T3, T4 at the nodes 1, 2, 3, 4. Now, once again, we know all the values at what? This n plus 1. Now you move to n plus 2. Now you move to n plus 2. Now once again we will end up with what? Unknowns only. Now once again you make n plus 2 to be what? N plus 1. And n plus 1 to be what? N. Finally once again we will end up with what? 3 unknowns. Once again we will have to go for what? This triangular matrix. The matrix will be same. Only the numbers will vary. I got the logic what I'm doing. Once again this matrix will be same, but the numbers will be no. This matrix also will vary because they are not keep on varying. So and the constants also will vary. So definitely it will vary. So we have to form once again the matrix and we have to solve it like a Thomas algorithm. We can get the values. So you may feel that the implicit method is somewhat quite difficult and is very hard. Why you want to struggle like this when you are able to do very easily and simply with the help of explicit method? Whether I'm right, whether you are thinking like that.
Yes, sir.
Yeah. Yeah. Yeah, fine. So, but the implicit method is a better method than the explicit method because it will not lead to any instability problem. In explicit method, now we are seeing this matrix is AX equal to B, a 4 by 4 matrix we are seeing. But if it's a one dimension, I have only 5 elements with 4 nodes. If I'm going to have 100 nodes, then you will have a 100 by 100 matrix. It's one dimension. If it's going to be 2 dimensional, you imagine 100 by 100 in the thing itself, then the matrix size. Then it's going to be 3 dimensional. Imagine this much big. Yeah, but still it is better to solve through implicit method. It has its own advantage. I can tell an example like this for you. I can tell a layman example. Don't tell it outside. It is just for your understanding. Don't tell a person like this. Don't tell the example. They will laugh at me. Now I want to carry, say, a bucket of water from the ground floor to the second floor, where I want to take some rest like that. Now, this can be done if I'm going to ask my daughter, who is 6 years old, she can carry in a small glass of tumbler. She can come and even completely fill the bucket full of water, but she has to come every time. What is her drawback? She can't take more than a tumbler glass of weight. So she can come a number of times up and down, and she can fill the water. There's no problem. She will be doing it. She can do it. It is similar to a explicit method. On the other hand, a person like me who is strong enough, I am having a bucket which is full of water. In one stretch itself, I can take all the water from the ground floor to the top. It may be difficult for me. I have to put some load. I agree, but it's easy to carry and stretch from one place to another place. Similarly, the implicit method can go for infinite time step for certain problem which is quite stable. So your R value instead of 0.5, sometimes you can even go for R value equal to 2, which means your delta t instead of 100 seconds, we can go even for 400 seconds, something like that. So here you can jump with more stability in case of implicit method, but in order to ensure more accuracy, even for implicit method, they will ask us to go in small marching. That is, don't keep a big step. Try to keep a small step. That is, don't keep R value to be more. You try to restrict yourself to 0.5. So each and every method, both explicit and implicit, has their own merits and demerits. And when the physics problem is going to be complex, better you can try to solve it through your implicit method rather than the explicit method. Okay, I am about to complete. This is completed. This is nothing but the coding. We have not solved by analytical method. We have solved this by numerical method. And this is nothing but through CFD. But this CFD problem is very simple in the sense there is no flow at all. Now the air is not at all flowing. Now the heat is only flowing from one end of the rod to the other end of the rod because of the temperature difference. Okay, so this is also a type of problem which we are trying to understood what is meant by CFD. But it's not complete CFD, but we can't deny it's not CFD. Okay, if you want, I can take you to Fluent and already the time is 6 o'clock. If you want, I can spare some 5 to 10 minutes of Fluent. Otherwise, I will stop here.
No,
I
sir.
do
Please,
not.
sir. Teach Fluent, sir, for 10 minutes, sir. 10 to
Fluent, if you're
15 minutes.
interested, I'm not forcing anyone. Please don't scold me.
No, sir. We are interested, sir.
Yeah. So I'll be explaining the Fluent. Yeah. Okay, you can see here. This is the Fluent window. I've already run the case and it's also converged. But how to do? I'm telling. File, read, and go to mesh. Okay.
Sir,
You
screen not shown, sir.
Yeah. I'm sorry. Still, there are 152 people are there. Yeah. Fluent. Yeah. You can see yesterday I gave the run in Fluent also with a different boundary condition, and you can see the solution is converged. I will tell what is the meaning of convergence. You see you can see what is the top where it's starting. Then only you can understand. Yeah, here. Continuity X. Continuity means mass. Continuity means what? Energy equation mass. X, Y, Z. That is for momentum. Energy for energy equation, which we are not dealt because of lack of time. Yeah. Then you can see K and epsilon. This was turbulence. And we can see the computer has taken a number of iterations and finally it has shown solution is converged. Solution is converged means it becomes, you see, these two values are almost same. It will be same up to the fourth digit. So we can see mass is converged, U, V, W is converged. Energy you can see 10 power minus 8. And you can see even K and epsilon, they have been converged because there is no variation up to the fourth digit for K and epsilon. There is no variation up to the seventh digit for the energy. There is no variation for the momentum as well as the mass. So we come to a conclusion the solution is converged. So this is converged. But how to set the case in Fluent, I'll come back to you from the beginning. If you want, I can also show the outcome of this one. That is post processing, but there's no time. So file, read, mesh. I'll be going real fast. Yeah, discard the case and data, read new mesh. Yeah, continue. File, otherwise I have to close and come. Read mesh. Yeah, it is there. Yeah, .msh. So the file which is openable in Fluent is .msh, mesh file. Give OK. No, it's not able to read because the case file is already there. So I will exit and I'll open it once again. Then I'll share the screen with you. Yeah. It is as Fluent. Yeah, so it is 3D. I will show the screen. Don't worry. I am about to open it. Then I will show you. Darima. I am sharing the screen. Yeah, here share screen, and I'm going to share this one. Yeah, I hope now we can see the screen. If everyone is able to see the screen.
Yes, sir. Yes, sir.
Yeah, file, read, mesh. So the file which is readable in Fluent is .msh. You go to the folder where it is. It is in E, this one. So .msh. You OK. So now is reading the mesh file. What we have. So Yeah, now we have read the file, and if you want to go for, you can go like this. Models, multiphase is not required because both are liquid, and even both are one is liquid, another vapor also you can take, but they're not going to mix. So multiphase is not required, but the energy should not be off. Energy should be on because heat transfer should have to take place. Because heat transfer should take from the hot fluid, it has to go to the solid. Then from the solid, it has to go to the which one? The cold fluid. So energy should be there. We have to solve for the temperature. Viscous, I won't agree. Definitely there may be some turbulence because if I'm going to give more velocity, there's a possibility of turbulence. So I'm going to give K epsilon, standard K epsilon. We are unable to discuss about the different turbulence model. I'm sorry. You may call me or ask me separately. I will able to answer you to a certain extent. There's no radiation heat transfer. Heat exchanger also off. Phase is off. Discrete off. All things off. Yeah, that's fine. Then you go to materials. You go. In the fluid is only air is there, but I'm not happy with the air alone. So I want to bring it this one, water also. So you can see here, I double click on air and the window is here. Then I'm going for fluid database because air is only there. I want to take water. So come to water. So water, I have both water vapor as water liquid. I want to take water liquid and copy and close. Now change grade, close. Now apart from air, we are also having water. Okay, now compared to yesterday class, what I have done today is through the inner tube hot fluid, I have sent the air, and the outside I have sent the water. It can be anything. It can be both water, one can be air, another can be water, or both can be air. Whatever you want, you can keep it. So nothing wrong in that. Similarly, solid instead of aluminum, I want to take copper. So how to make copper? Double click on aluminum. You go to fluid database. Instead of now you still we are having only water. Why? Because it is fluid. You convert the fluid to solid. You take a titanium steel or something. Titanium, if you are going to put somebody will come and steal our heat exchanger. So better to put only copper. Even they'll steal the copper today. So copy, say close, and you can get change grade, close. Now you can see copper as well as aluminum for the solid material. For the fluid, we have water and air. So the fluid domain. It is
ஒண்ணுல ப்ரௌசர் நீங்க உங்களுக்கு சைன் இன் பண்ணிட்டு இந்த 8 ஆப்ஸ்ல போய் கூகுள் காலண்டர் போனாலே இல்ல
some disturbance is there. Yeah, cell zone condition. Here you can go fluid hot. I am going to make it what fluid and edit. What you want in the hot fluid, whether air or water. Let us have water. Better we can have water instead of air. I can have liquid water. Yeah. Give okay. So in the hot tube, I am going to send the water, and in the cold fluid, I am going to send the air. Okay, it's possible. I am going to send the air. Got it? What I'm telling? Just you move down, you will get the answer. Slowly you go by step by step. And after this, you go to solid. So which solid you want? Whether you want aluminum or copper? I want copper. So you give copper. So now I define the fluid through the tube is your water, and the fluid through the shell is your air, and the solid is your copper. Yeah. Then you come to the boundary condition. It is a fluid is somewhat easier compared to CFX. For me, both are okay. Yeah. Now we can see here. These are the different boundary conditions. Okay. So what is the velocity of the cold fluid at the last? I will just go with the hot fluid inlet. So yeah. Now what is the? I will change it. Here it is there. Inlet hot fluid. So what is the velocity type? Velocity inlet. Apart from the velocity inlet, what are other things you can give? You can, if you are knowing the mass flow, you can give mass flow. Okay, but don't give other things. You can don't give even pressure for water. It's better to give either mass flow or velocity. We'll give it the what we can give. We can give it the mass flow. Nothing wrong. We can give some mass flow as inlet for the hot fluid. Now the hot fluid is going to come at 1 kg per second. Let us say it is coming as a 1.5 kg per second. Let us see. Yeah, what is the temperature is coming? Is not going to come at 300 Kelvin. It is going to come at 360, 370 Kelvin, because 373 will become vapor. So I'm giving 370. That is the hot water at 1.5 kg per second is entering through the hot tube at a temperature of say nearly 97 degrees Celsius, which is equivalent to 370 Kelvin, and give apply OK. So what about the inlet outlet cold fluid, outlet hot fluid, hot fluid? Yeah, it is, don't give outlet vent. You better prefer pressure outlet. And yeah, you simply, as yesterday we given 0 Pascal, here also you can give 0 Pascal. Thermal, you don't worry, it is atmospheric temperature. So I am giving 300. Here the temperature of 300 indicates the atmospheric temperature. If you are going to be in foreign countries where the temperature is very less, you can even use still lesser values. But it will not affect much. Okay. Then, yeah, we have completed the hot fluid. Now let us come to the cold fluid, inlet cold fluid. So the cold fluid is air, and I'm going to send the air, and here instead of mass flow rate, we can give the velocity magnitude. Let us say the velocity of the air is coming is 0.2 meters per second or 1 meter per second, nothing wrong. What is the value? What is temperature is coming? Let us say it's a cold one. So let us say it is 275 degrees Celsius. 275 Kelvin is equal to 2 degrees Celsius. So air is coming at 2 degrees Celsius. Okay, that's fine. Then we have to check once again. Yeah, thermal momentum is there. Give out. Okay, yeah. Then outlet cold fluid. Yeah, this is outlet cold fluid. Then we can go for the pressure outlet. Yeah, the Pascal is 0. Give okay. That's it. Outlet you give pressure outlet. That's it. Now shell wall is adiabatic. Now the beauty of the fluid is there's no need to create any interface. As I told you in the morning, it will create a shadow on its own. Shadow means the other surface. So they both will create another one surface, and automatically it will create the interface. So there's no need to create any interface in case of our fluid. One more point I want to tell. I have missed the general tab. This general tab you can go for scaling. So now you can see it is somewhat meter and all. So please change it to millimeter, and mesh was also created in what? Millimeter. You give scale. If you are going to miss this one, entire answer will be wrong. Now you are right, because so we are having this 50. I hope now is right. So don't forget to do this step. Is very, very important. Yeah, and if you want to check the quality also, you can check. Yesterday I told about the quality checking in free end. That also I am about to tell here. So you can see the minimum volume is not negative, it is positive. Sorry, one phone call came, so the connectivity gone. Yeah, this one and share. I hope now you can see once again. Yeah, that's it. Now that is the point I missed there, and you can check the scale. And if you want to display, also you can display. What are the things you get? Yeah, close. And if you want to see the mesh, you can put this one. Yeah, now you can see. This is the fit into screen, and this is a screen to rotate. If you want to rotate and see, yeah, this is the mesh what we did yesterday, isn't it? So if you want to see the mesh also, you can see. So after this, yeah, we are almost completed. Reference values, we don't take the values. Methods, yeah, here is simple method. How we are actually this concept, I have to take half an hour. I can't explain you now, so I'm not going to explain you now. Semi-implicit pressure linked equation. How the kinetic equation and momentum equation are going to combine with each other. There are how many variables in momentum equation? There are 4 variables in momentum equation. What are they? U, V, W, and P. P is pressure. U, V, W, and P. In continuity, how many variables are there? There are 3 variables, U, V, W. Even though we have 4 equations and 4 unknowns, but the pressure variable is not linked with the continuity equation. So we can't solve them to proper mode. For that only we need simple. Even though we have 4 equations, 4 unknowns, but one unknown is available in only 3 equations and not in the continuity equation. How we are going to solve all these things will be explained by simple. This is the least way. This is a very juicy way I can tell to you, but you have to go very deep into that. I can go ahead. Then you can see how we are going to solve it. What is second order pressure, momentum, all these things we have to explain, but there's no time as of now. We are going to the controls. Control also don't change any values. It's a default value. It will work fine. Report, whether you want to report some outcomes like what we have done yesterday for monetary points. Now I am not going to do due to lack of time. It's not required also. Monitor also yesterday like that what I told. Yeah, it is going to plot the residuals and it's going to plot 1000. If you want, you can change 1000 to 10,000 also, but 1000 is more than sufficient because we know it gets converged by 100 iterations. Yeah, convergence condition. You can see here convergence conditions. Okay, then you can come to insulation is very important because a transition problem. So you give insulation. Sometimes if you set the case wrongly, here also it come out of the insulation. So in fluent bond CFS also, if it's not getting insulated properly, there's a it will come outside. So it should be. This is one of the checkpoint we can tell. So now your question may be asking which type of insulation will be better, hybrid or standard. There's no time to now explain. In future, you can try by yourself. Because already the time is 6:10. Morning also we have taken half an hour extra. But since I want to give an insight about Fluent, I am going with this one. You see, it is taking some time because the number of nodes is nearly 12 lakhs. If it's going to be somewhat lesser, the time may be lesser, but it is more now. Yeah, still is rotating.
Hello.
Yeah.
Professor, I have one doubt.
Yeah, please.
Yeah, it is. Hello.
Yeah, please.
Whether the boundary condition is suitable only for Fluent, that is ANSYS Fluent, or else we can make it other like CFX and all.
Yeah, boundary condition is the same for both the Fluent and CFX. The same boundary condition you have to give. Then only you can compare which is better.
Okay, Professor.
Yeah, here also you have to give air. There also you have to give air. Here also you can give water. Here also give water. Yeah, there is one more boundary condition in a CFX. It's called as ambient or atmospheric. So we'll try to replicate as a atmospheric boundary condition, which is not available in Fluent. In Fluent, we have to give only pressure outlet. That's the only difference. Yeah, now the insertion is over because it stopped rotating. There's no problem. Then calculation activities. Yeah, if you want to save anything, save after 100 iterations, like what I told you yesterday, to have backup. Okay, that is the thing, auto save option. Then we can go for run calculation. Yeah, run calculation. Now, how many iterations you want? I want some 1000 iterations to run. And if I'm going to give calculate, it will solve. It will start iterating. Yeah, now only starts iterating. You can see continuity is nothing but your mass equation. Mass x, y, z indicates your momentum equation. X momentum, y momentum, and z momentum. So we have seen up to here. We have not seen the energy equation. And this is nothing, we have not seen this also. Turbulence, K epsilon. Now this is going to work for the, this is nothing but solver. Until now it calls preprocessor. Now the computer is doing some work now. This work is called as solving. It is solving the continuity equation, momentum equation, energy equation, and turbulence equation. After this, we can see the post-processing. Just like I shown solutions converge. After that, you have to take the solution and you have to check for the answer. I'm happy that I'm able to cover the Fluent also. As well as I'm thankful to you because you are stretching your time beyond the limits. So with this, I wish to hand over the section to Dr. Priyasamit sir.
Sir,
Yeah, please.
sir, thank you, sir. Thank you so much. You will be able to see the chart box.
I have not seen. This,
So that's a wonderful learning of CFD. So many
Okay.
people are very much praised you. There is no word to praise you also, because I know that you are an expert in that particular field. We also interacted at the VIT as well as VIG Tech, etc. So I thank you very much, sir. So the participants can submit the feedback today, and then you can take a 1 week for submitting the assignment. The assignment, suppose you don't have any software, you please describe the procedure and missing criteria, then other output, what are the possible output you can take from that one, and make it that as a PDF, then upload. That is enough for us. That is, you learned from this one by how to create a model, how to create a mess, how to solve, then what are the output you can learn, take from that one. That is our aim of that question. If anybody have a sophisticated software also, you can do and upload. That is very much appreciated. Thank you, one and all person here. Thank you, our resource person also. Thank you, sir. Thank you.
yeah, thank you, everyone. Yeah, thank you.
Thank you, Professor. Thank you so much, sir.
Thank you, sir.
Thank you, sir. Thank you.
Sir, we need to share feedback here, sir.
Thank you, 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 Professor.
Thank you, one and all.
Thank you, Professor, and coordinators for the coordinators.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.